Um, come on, what's going on? Okay. Uh, I'm sure you guys know the tutorial sheet for today, which is on the course website. So if you go to the course website, um, let me show you. Okay, you go to the course website and go to week 9. Um, this is the tutorial sheet. This is the tutorial sheet for today. There are 7 questions, and I will try to go through as many as possible as usual. Okay, and all your questions, please feel free to use the chat room. Okay. Um, okay. Right. Okay. Let me change the camera. Um, so I'm not sure if you can see this clearly. If not, the course website. You can see it more clearly in the course website. What I'm talking about. Okay. All right. So let me start with question number 7. Right. Uh, so I'll start with question number 7 first, which is the last question on the sheet. Okay. The um, There are several parts. There is 4 different parts to this question 7, right? The first part is asking you, if you have 2 variables, if you have a variable x and a variable y, which is defined as ax plus b, what is the mean and the variance of the variable y in terms of the mean and the variance of the variable x, right? So mu y, which is the mean or the population mean of the variable y, right, is equal to this, yeah. And now if you take the expectation inside, this will be a times the expectation of x plus b, right? And the expectation of x is denoted by mu x in the question. So this is the mean or the population mean of the variable y. And the population variance of the variable y, yeah, is this, yeah. And if you take the variance inside, you get a squared times the variance of x. Now b does not change the variance. I'm sure you know this from probability 1. So this is a squared. The variance of x is denoted by sigma x squared. Right, so this completes part 1 of question 7. Right, now to do part 2, is asking you for the sample mean and the sample variance of the y's in terms of the sample mean and the sample variance of the x's. So let's look at the sample mean of y, which is, I'm sure all of you know, this is the sample mean, the definition of sample mean. So this will be 1 over n times the sum okay. Right, now if you take the sum inside, this is what you will get, yeah. Okay, now this is going to be 1 over n times a times the sum of xi. Now the sum of b B, because B is a constant, guys, it is just simply n times B, right? Okay. Right now, if you divide by n, this is what you get, right? Okay, now this is now this guy here is the sample mean of the x's, right? Plus B, right? Are you guys okay with this? Hello, talk to me, guys. Hello, are you okay with me so far or not? Okay, thank you. Right. Okay, now the next thing I'm going to do, okay, this expresses the sample mean of the y in terms of the sample mean of the x's. Now the next thing I'm going to do is the same for sample variance. Now remember the sample variance. The sample variance is defined as follows. You may recall this from much early on in the course. Okay. This is the definition of sample variance, the unbiased version, right? Okay, now we know that from the question number 7, that yi can be expressed as axi plus b, right? And we know from the part that we just completed that y bar is ax bar plus b. Okay, so these two guys cancel out, right? So what you get is 1 over n minus 1, the sum I from 1 to n of a squared xi minus x bar squared, right? A squared is a constant, so you can pull it outside. So this becomes a squared times 1 over n minus 1 times the sum I from 1 to n of xi minus x bar squared. Okay, now this guy here is the sample variance for the x's. So this will be a squared. Okay. All right, guys. So that completes part 2 of question number 7. Right. The next question, part three of question 7 is asking you about the confidence interval, right? Now, suppose what you're given in part 3 is the following. Suppose this is u, okay, not to be confused with mu. Suppose this is a confidence interval for mu x. Mu x, remember mu x is the population mean for the variable x, right? Now what this implies is the following. This implies that the probability is this, right? You follow me? Yeah. Okay. Now from this statement, we can, what I'm going to do is I'm going to multiply everything within the probability by a. Remember, a is a positive constant, so I don't need to change the sign. Okay. And the next thing I'm going to do is I'm going to add for each of these terms the constant b. Yeah. And we know from the first part of this question, the part 1 of question 7, that this guy here is the population mean for the variable y. Okay. Right now, what this implies is that, guys, what this implies that is that the probability that the population mean for y lying between these two is 1 minus alpha. So what we have shown, is that 100 times 1 minus alpha percent ci for mu y, right, is the interval from the lower limit is this, and the upper limit is this. Okay. All right. Okay, guys. So that completes part 3 of question number 7. Is that okay? Or any questions so far on this? Okay. So this is the confidence interval for the population mean of y. Okay. Okay, thank you, guys. All right, the next question, the next part, there are 4 different parts to question 7. So I'm going to do the last part now. So this is question 7, part 4. Okay, right. So right now according to this question, what is given is the following. You are given that 100 times 1 minus alpha percent confidence interval for sigma x squared is the following. V okay, this is given to you, right? So this implies, guys, that the probability that sigma x squared lies between Vx and Wx is 1 minus alpha, right? Now what we are asked to find is the confidence interval for sigma y squared. Now remember from the previous part, all right, but okay, before I talk about that, let me multiply each term by a squared, right? Okay, remember a squared is a positive constant, so we don't need to change the sign. Now we know from the previous part that this guy here is the population variance of y. All right, so this is the probability that a squared Vx less than sigma y squared less than a squared Wx is equal to 1 minus alpha. Okay, all right. So this implies that 100 times 1 minus alpha percent confidence interval for the population variance of y is the interval from a squared Vx to a squared Wx. All right, so this completes the final part of question number 7. All right, guys, are you okay with this? Or any questions on any of the 4 parts of question 7? Hello, guys, talk to me. Are you okay or not? If it's not okay, just fine. I'm happy. If that's not okay, I'm happy to go over again. All right, so that's question 6. So I'm done with question. All right, I just done with question 7 rather. So the next question I'm going to do is question number 6. So this is done. Question 6 is this one. You can read it off the computer. So basically it says that certain adult male population blood pressure is normally distributed with mean mu and variance sigma squared. And you have a random sample of 30 from this population, which gives the result. This is the sample mean and this is the sample variance, right? And the question is to find 98% confidence interval for mu and the 98% confidence interval for sigma squared. So there are two different parts to this question. Right, now this is where this comes in. I'm sure this is stuff that we did about 2 weeks ago or 1 week ago. I can't remember now. These are the 4 confidence interval I gave you. This is the confidence interval when, excuse me. This is the confidence interval when for the population mean when the variance is known. And this is the confidence interval for population mean when the variance is unknown. And this is the confidence interval for the population variance. And this is the confidence interval for the population proportion, right? Now, in this question, the question that we're looking at right now, which is this, right? Which is this one, is asking you for the confidence interval for mu and the confidence interval for sigma squared. Now, in this case, the population variance is not known. So the one we need to use, excuse me, the one, okay, in order to find the population mean for the mean, we need to use this one. And in order to find the confidence interval for the variance, we need to use this one. So these are the two that we need to use for question number 6, right? So that's what I'm going to do now. I hope you guys follow me, right? Or no? If it's not, if it is no, just let me know, okay? All right, so this is for question number, this is question 6, right? Okay, what we are given. So the first thing is the confidence interval for mu. All right, so just look at this one more time, right? The one we're going to use is this one, right? So it's going to be x bar plus or minus t okay, this is all right. Now we know from the question that x bar is 127.442, and this guy here is t n minus 1, n is 10, right? So n minus 1 is not, sorry, n is 30, right? N is 30, right? Yeah, n is 30. So n minus 1 is 29. Your alpha, 100 times 1 minus alpha is 98, right? So your alpha, your 1 minus alpha by 2 will be 0.99, right? Okay, and s is the square root of s squared, which is given as 228.66, right? And n is 30, so this is the square root of 30, right? Okay. All right, guys. Did you see how I got this or not? Hello, guys. Yeah. Okay. All right. Now you should simplify this sum here. I mean, you should simplify this, guys, using a calculator. You will get 120.64 as the lower limit and 134.24 as the upper limit. Right. All right. So that's the confidence interval for the population mean. And the confidence interval for population variance, okay, according to this formula here, the one I'm going to use is this one here, right? Okay, this is the formula I'm going to use. Okay, so let me write it down. It's going to be all right. How do you find T29? I mean, you need to use the table, madam. do you have the table for the t distribution, which I explained to you last week? If you use the table, if you look at the table for the t and the degree of freedom 29, you will get it. Okay, right. Okay, this is the formula for the population variance, the confidence interval for the population variance, right? Now this, as you may recall, this is the same as the numerator is the same as n minus 1 times the sample variance, right? Um, and the same thing here. Okay, now n is 30, so it's 30 minus 1 is 29. S squared is given to us as 228.661 divided by the chi-squared with degree of freedom 29. 1 minus alpha by 2 will be 0.99, right? Okay, and then comma, n is 29, n minus 1 is 29, 228.661 divided by chi-squared 29. Alpha by 2 will be 0.001, right? Okay, so this is what you get, right? Now if you simplify the numbers, you will get the lower limit as this and the upper limit as 465.15. So this is the 98% confidence interval for the population variance, and this is the 98% confidence interval for the population mean. Right, any questions on this? So basically I have used, it's a matter of using one of the four formulas here. This is the formula for the confidence interval for the population mean when the variance is known. This is when the variance is unknown. This is the formula for the confidence interval for the population variance. And this is the formula for the confidence interval for the population proportion. So in this question number 6, I have used this one and this one, all right? And to read the percentiles of the t and the percentiles of the chi-squared, you need to use the tables. You know where to find the tables, guys, don't you? I mean, the tables are on the course website, guys. So if you go to the course website and click on the link, there's a link called formulas, right? If you click on the link called formulas, you will see the tables for the t, the tables for the chi-squared, and the tables for the normal. Okay, you will see all of them there.
Sir, I see from the table for t distribution, we don't have 29. We have 30. We take the value of 30.
In that case, you can approximate the one with the 30. Yeah. Yes, ma'am. Thank you. Any other questions, guys? Hello. How's it gonna be? The exam will be closed book. Yeah, the exam will be closed booked, and you will have 2 hours to do the exam. I think I sent you the time, the date and time for the exam last week. Did you get my email? I'm sure you did. The exam will be 2 hours long, and you can write down the answers from wherever you are. Yeah, and after 2 hours, you will be given like half an hour extra time to upload the answers to Blackboard, and I will mark all of them, all the questions. Okay. All right, guys. All right. So let me move on to the next one now. Question 5. So this is question 6. We are done. So the next question is question 5. So we're done with question 6. Question 5 is this: you have a psychologist measurement of reaction are normally distributed with sigma 0.05. What are the numbers Something is going on. Just be patient with me, guys. I think there is a problem with the camera. Hello, guys. Just. Okay. I'm back now. I'm back. Okay. Okay. Thank you. All right. So the question is, what are the number of measurements that must be taken so that 95% and 99% confidence interval for the mean reaction time has a width not exceeding 0.02, right? Okay. All right. So to do this question, so this is question 5. Let me go back. This is question 5. Okay. So basically, you are given the population standard deviation in this question, and you're talking about the confidence interval for the population mean, right? So the formula that we need to use, is clearly this one, right? Because this is the one for the population mean when the population variance is known, and the question gives you the population variance as 0.05 as the population standard deviation. All right, so we're going to use this formula. Okay, right. So the confidence interval for mu is x bar plus or minus okay. Now the question is talking about the width. Remember, the width of the confidence interval, yeah, is gonna be the difference between the upper limit and the lower limit. So right, the upper limit is, this is the upper limit, minus the lower limit is all right, this is the lower limit. So if you take the difference of these two guys, you will get 2 times so this is the width, right? Now we are told that that sigma is 0.05. Okay. So this becomes 2 times 0.05 is 0.1 times z1 minus alpha by 2 divided by the square root of n, right? And this is the width of the confidence interval. And if you go back to the question one more time, it says that they want the width means, excuse me, it plays around again one more time. I don't know what the problem is. What's going on? Just a minute, just hang on with me, guys. Just stay online, okay? Just don't disappear. Okay, thank you. I think I'm back now. Okay, so they want the width not to exceed 0.02, which means it must be less than 0.02, right? This guy here must be less than 0.02, right? So which is the same as saying that root of n must be greater than 0.1 divided by 0.02 multiplied by this guy here. All right. So which is the same as saying that the root of n must be greater than or equal to 5 times this, right? So in other words, n must be greater than or equal to 25 times okay. So this n is the sample size, all right? So must be greater than or equal to this. All right, now we need to consider the two parts. You should go back to the question. It says, it's asking you to find the 95% and the 99%. So for the first part, let me do it on a fresh page, right? For the first part, which is for the first part, we want 100 times 1 minus alpha to be equal to 95%, which implies that alpha must be 0.05, right? And this implies that z1 minus alpha by 2 will be 1.96, right? Okay, guys. So you should call this equation star. Let me call this, just for the sake of notation, let me call it star. So star implies, right, that n must be greater than or equal to 25 multiplied by 1.96 squared, right, which is approximately 96.04, right? So in other words, n must be greater than or equal to 97. All right, do you see how I got this? Right, you're just using the equation star. Right now, that's when n for 95. And we are also asked to find what happens when it's 99%, right? Okay, in this case, your alpha will be 0.01, okay? So your z1 minus alpha by 2 is gonna be z 0.995, and this will be 2.58, yeah, okay? All right, so once again, using star, going back to star one more time. So it follows from star that n, the sample size, must be greater than or equal to 25 times 2.58 squared, right? So this, if you simplify this, this is 166.41. So in other words, n must be greater than or equal to 167. Because remember, n must be an integer, so it cannot be 166.41, right? All right, guys, so this completes the solution to question 5. Are you okay with this or not? Hello, guys, talk to me, please. Are you all okay with this? Yeah. Okay, thank you. Thank you very much. So that completes question 5. Okay, let me move on to the next question, which is question 4. So we're done with question 5. Question 4 is, it has several parts. So here you have a random sample from this. Mu is unknown, but sigma squared is known. What is the width? Which variables affect the width? Okay, and so on. Okay, so let's see how we can do this. So this is question number 4, the tutorial sheet. Right. The question is, once again, is talking about the confidence interval for mu. Yeah. Which, because if you read here, guys, it says the sigma squared is known. That's the crucial part. So the confidence interval for mu when sigma squared is known is this one, right? This is the confidence interval, okay? So I'm gonna write it down. So the confidence interval is x bar plus or minus okay? So the width of the confidence interval is the difference between the upper limit and the lower limit, right? So which is right. This is the difference between the upper and the lower limit. So this will be 2 times okay. So this is the width, right? This is the width of the confidence interval. Now, the question is asking you what happens to the width with respect to the parameters in the formula. Right, now I'm going to explain this to you. Now, the parameters that control this formula are the following. There is alpha, right? And there's the parameter sigma, and there's a parameter n. These are the 3 things that are in this formula, right? Now, I'm going to explain how each of these affects the value of this width, right? Now, as alpha increases, right? As alpha increases, right? This is, I don't know whether you're familiar with this notation. This means alpha increases, Z1 minus alpha by 2 decreases, right? Okay, so the width, will decrease with the width will decrease with increasing alpha, right? Now, as sigma increases, now remember sigma is on the numerator. So as sigma increases, the width will also increase. Okay, right? And finally, as n increases, because n is in the denominator of the formula, right? The width will decrease, right? All right. So you see what I, so these are the 3 things that control the formula for the width, right? So as alpha increases, Z1 minus alpha by 2 decreases, so the width will also decrease. As sigma increases, the width increases because sigma is in the numerator. As n increases, because n is in the denominator, the width will decrease, right? Are you guys okay with this so far? Hello? Hello, guys. Are you okay with this? Yeah. Okay. All right. The next thing the question is asking you to tabulate. It's asking you to tabulate the values for the width for n equal to 5, 15 up to 100 for different values of alpha, right? So that's what I'm going to do now. Now, what I'm going to do is I'm going to have a table. I'm going to create a table with these values for n. Okay, and the alpha takes the values either 0.1 or 0.01. Now, sorry, 0.01. Okay. Now, in this table, what I'm going to give you are the values of this. So for each combination of n and alpha, I'm going to compute this guy here, right? Okay. So if you do the math, if you have a calculator with you, you can do this quickly. This is what you will get. Okay, so these are the values that you would get for the width given by this formula. All right. All right. The next thing I'm going to do is to plot. The question is asking you to plot these values versus n for alpha is 0.1 and alpha is 0.01. Right, and if you do that, this is what you will get. All right. So what I have done here is to plot using R. So the dotted line here corresponds to the values of width when alpha is 0.01, and this line here corresponds to the values of the width when alpha is 0.1, and the n goes from 5, 15 up to 100. Okay. Okay. So as you can see, as n increases, the width decreases, right? Okay. And as you go from alpha equal to 0.1, which is this one, to alpha equal to alpha equal to 0.1, which is this one, to alpha equal to 0.01, which is this one, the width increases, right? Okay. All right, guys. So this completes. Have you been able to follow this? Okay or not? So this is the solution to question number 4, right? Are you okay with this or not? If it's not okay, please let me know. I'm happy to go over again if you want me to, right? Okay. So that's question 4, and the next question I'm gonna do, if I have time, I will do it. All right, is this one. So I'm done with question 4. Question 3 is this. You have a random sample of 500 household. 80 were found to have 3 or more TV sets. Find an approximate 90% confidence interval for the proportion of household who have 3 or more TV sets. Right, so in this case, the question is about proportions. So clearly the formula that you need to use, I mean, of these 4 different formula, the one you need to use is this one. So this is the formula I'm going to use, right, to do this question, right? So I'll do this quickly because I'm running out of time. So this is question 3. So the formula I'm going to use is x bar plus or minus z 1 minus alpha by 2. Okay. Right, now we are given the following. We are given that n is equal to 500. X bar is the sample proportion, which is 80 divided by 500. 80 people out of 500 household have 3 or more televisions. So this is 0.16. Now alpha is 90%. So in other words, 100 times 1 minus alpha is 90. All right, so your alpha is 0.1, right? So your z 1 minus alpha by 2 is gonna be 1.6449, right? So given all this, so this is what we are given in the question. Now if you sub this into this formula, if you sub this into this formula, this is what you will get. You get 0.16 plus or minus 1.6449 multiplied by 0.16 multiplied by 1 minus 0.16 divided by n, which is 500. Okay. All right. Now, if you do the math for this, the lower limit will be 0.133. The upper limit will be 0.187. So this is the 90% confidence interval for the proportion of people who have 3 or more television sets. All right, guys. Any questions on this, guys? Please let me know. Are you okay with this or no? Hello, guys. Talk to me. Are you okay with this? Okay, thank you. Right. So that's question 3 is a really short one. The next question is question 2. So I'm done with this. So we're done with question 3. So I'm going to move on to question 2. Question 2, you have a random sample of size 30 from a normal, and you are given this and this, and the question is find a 95% confidence interval for mu when sigma squared is 30, and mu and sigma squared when both are unknown. Okay, so to do the first part of the question, you need to use this formula here, because we are assuming that the sigma squared is known, right, to be equal to 30. Right, so let me do that. So this is question 2, part 1, right? So the formula I'm going to use, right, is this: x bar plus or minus z 1 minus alpha by 2 sigma by root of n. This is the formula I'm going to use. X bar is given to us as, if you read the question here, you are given the sum of xi as this. So x bar is simply 1568.45 divided by 30. That's your x bar. Plus or minus, we are looking for 95% confidence interval. So your alpha is, your this thing is gonna be 0.975, and your sigma is given as 30. So this is 30 divided by root of n is given as 32. So sigma is also 30, right? Sigma squared is 30, so sigma is square root of 30, right? Now, if you do the math for this, right, the confidence interval will be 50.32 is the lower limit, and 54.24 is the upper limit. Okay. All right, guys. So this is what you will get for part 1 of question 2. For part two, we need to find the confidence interval for mu and sigma squared when both are unknown. So for that, you're gonna use this formula for the mean to find the confidence interval for the mean, and you're gonna use this formula to find the confidence interval for the variance, right? So I hope you can do that by yourself, and because I run out of time. And for question 1 is pretty straightforward. Question 1 is just to find here you are given the mean scores and the sample standard deviation, and you're asked to find the 90% confidence interval. So you can use this formula here to do question 1. Okay. All right, guys. So I haven't done question 1 and part of question 2, but you should be able to do them by yourself. But on Thursday, I will post all the full solutions to all the 7 questions on Thursday of this week. So there will be three types of solutions. There will be the typed solution, there will be the handwritten solution, and there will also be like a video solutions for all 7 questions. Okay. Okay, guys. So I hope you're okay. So have a great day, and please keep safe. Okay. And any questions, as usual, please feel free to contact me 24/7, right, by email, Skype, Zoom, or phone. You know my phone number. Okay, which is 01612732941. Okay, take care, guys. Bye.
Have a nice day, sir.
Yeah, you too. You too, guys. Bye.